I'm Vigdis, as he mentioned, and I'm here to talk about how to harden Enonic XP by using security headers, and I'll focus on give more details on the content security policy, as that's the one that we'll need more details on. Yeah, first I'm just going to give a short introduction to who I am and why I'm here, and then we are going to go through the security headers, and then I'll give a short demonstration of how to use it in Enonic, and then short with key takeaways, and we have time for questions in the end. So I am Vigdis, and I am a tech lead and web developer at Bouvet, and I work in our team Enonic, and we are 9 developers that maintains and develops 18 solutions for 11 different customers on Enonic. And I have been in Bouvet and worked with Enonic solutions for almost 7 years. And I'm here today to talk about security headers, because I have implemented this in both new and existing solutions, so I have a bit of experience with it. And I also work as a security champion on our team Enonic when I have the time to do that. So the first header is the strict transport security header. It's an HTTP header that tells the browser to use HTTPS and handle TLS and certification errors. The only thing you have to use here is the maximum age. This specifies how long a browser should remember that the domain should only be accessed through HTTPS. You can also use the include subdomains, which does exactly that, include the subdomains on your page, and tells the browser to use HTTPS on them as well. And then you have the preload option. If you want to use this, you also have to register at an official list that all the browsers will get this information from and know that your domain should always load on HTTPS, even though a user haven't visited your site yet. This helps mitigate SSL stripping attacks, which is a version of man in the middle. Then we're going to look at the content security policy. It's also an HTTP header. It gives fine-grained control over resources and how we can use it. It helps prevent cross-site scripting, clickjacking, and manipulator in the middle attacks. These are some of the common directives. For example, script source here is used to tell the browser which pages or how we can load scripts and how we can use it. And then we have a lot of others. And the frame ancestors specifically, it is used together with another security header that we are going to look into later, and helps control how our page can be embedded. And there are also some of the new script source and style source specifications, but yeah, not all browsers. I think most modern browsers use them, but script source is the one we use the most. Values in each directive. Here are some keywords. You have none, which means that you cannot use a resource of this type. For example, if we had added that to the script source, then you wouldn't be able to load any scripts. Self means that we can only load, for example, scripts from our own origin. And unsafe inline is also a possibility, but if you can avoid to use it, please do, because it allows unsafe inline scripts to load. Use allow list and hash or nonce instead. Allow list is, for example, if you want to add YouTube to your web page, then you can allow, for example, youtube.com to run. If you need static script or style from your own web page to load, you can use the hash. And if you know that it can vary, use a nonce. We'll look into this later in the demonstration. These are also mentioned because the default source, that is where everything else goes to if you haven't set it. So for example, if I only added default source to none, then not scripts nor anything else will load if you haven't specifically set that. Yeah, in scripts we are allowed to do this. And you should also set these other 3, just because they do not default to the default source. so you are sure that you actually have covered everything and know what your page can load. I'll just mention this header because it is deprecated, but if you need to support legacy browsers, you can use it. If not, do not use it because Mozilla has documented that in some cases, this header can create cross-site scripting vulnerabilities. So only use it if you need to support legacy browsers. Xframe options is another HTTP header, together with the frame ancestors that I mentioned earlier in the content security policy. This can also help to control how our page can be embedded. It helps prevent clickjacking attacks. If you use the word deny here, the value deny, this page cannot be used in an iframe. If you use same origin, it allows iframes to be displayed, but only if all parents and ancestors have the same origin as your page. Yes. X-content type options is an HTTP header for MIME type verification. Its only valid option is no-sniff. It informs the browser to only load scripts and style sheets if the server have specified the correct MIME type. It was introduced in Internet Explorer 8 because before that, non-executable MIME types was able to run as executables. So use this. Referrer policy, an HTTP header which controls referrer info in a request. The normal referrer info is the origin, path, and query string. The downgrade keyword that you can see some places here refers to that you go from HTTPS to HTTP or HTTPS to a file. And I'll not go through everything here because I don't have the time to do that, but no refer means that you don't include any of these. And the default one, the strict origin when cross-origin, the one here, is will send everything, all of these, if you are on the same origin, and if you are on a cross-origin, but you do not downgrade, then it will only send origin. If you downgrade, you will not send anything. And the last one, before a demonstration, is the permission policy. It's experimental, but it can allow or deny browser features to be used. For example, autoplay, Bluetooth, camera geolocation. It is 40 other features as well, so I didn't care to list everything. But I mentioned this because OWASP recommends that you set and disable all features that your site does not use and allow those you need to do. Because attackers can use it even though it's experimental and won't work very good, maybe, in your application, but yeah. Then we are going into the demonstration. Let's see. Yes. Here we have an Enonic XP page, and I have installed some general applications, and I'll add the security headers application and configure that. So the first one is the strict transport security. You can add it here, but if you are in Enonic Cloud, for example, you should only configure it there. If you add it here as well, then your web page will actually tell the browser to use this header twice. So I'll remove it because I usually work in Enonic Cloud, and that is configured there. And I'll come back to content security policy later. So we go to X-frame options, and I want to use same origin. And that is because Enonic uses an iframe to display your web page in the preview and edit mode. So I want to use same origin because I want to be able to use Content Studio as I expect. Cross-site scripting protection, I will not support legacy browsers, so I'll not add that one. X content type options, I'll add the only valid option, no sniff. Refer policy, I'll just add no referrer for now because I don't know that I need the referrer info. And permissions policy will do exactly as OWASP recommends. And I'll just deny everything because I don't know of anything I'll need at the moment. There, then we have set some of the headers already. And then we'll look into the content security policy, which have a bit more detail. The first thing I want to do is add the default source, base URI, form action, and object source, as these should be a foundation, because everything else, as mentioned earlier, goes back to default source, except these three that you should set yourself. I'll go to none here because I know that I want to specify everything, particularly later. And we can just see what happens when everything defaults to deny. Here in preview, they don't use our content security policy that we have configured in the security headers right now. So we'll go to preview, and here nothing loads except our plain HTML. We'll see here that our style is denied, images and JavaScript is denied. So we have to open that. Then we go back here. Script source, I want my own scripts to load, and I want my own images to load, and my styles to load. Apply. And preview. That looks a bit better. But this image is a bit big. Here it's smaller, because our editors have changed it to be 40% or something like that of the width. And it has been using the rich text editor from Enonic. So, and the rich text editor uses inline styling. So if you want your editors to be able to use the rich text editor openly as without configuring more specific content security policy, you have to use the keyword that we won't use as much as we can at least, unsafe inline. But I'll do that for now, because I won't go and check if they accept both with 40%, with 41%, and so on. And then I think I applied it. Maybe I forgot. Apply, preview, there. It works. Hooray. Then we'll go to our weak plans, and here, oh, our editors have added YouTube video, and it's blocked because I haven't allowed YouTube here. And Chrome actually tells us what has happened. It refused to frame YouTube because it violates the following content security policy directive. It defaults to the default source because frame source was not explicitly set. So it uses the default source, which we set to none, as a fallback. So we will allow this frame to load. We'll go back to security headers and find our frame source here. And I'll also add, while I'm at it, I'll also add Twitter and Instagram because I know that the social macros app that I have installed as well gives this opportunity, and I want our editors to be able to use that as well, if they want to. Apply, and then we'll refresh this, and hooray, YouTube loads. And then we are going to look at specific code in our own project. I'll just build it again because here. Then we are going to talk about nonces while this built. Nonces are used for scripts that you need inline or that you need to load from your web page, but that can vary. For example, I have a script here that is needed by Facebook if you want to add a like button. And I want our editors to be able to use inside config, configure the app ID and version. And if they change the version and update it, then I want it to still continue working without me having to configure something in the content security policy. Then I can use a nonce, and this is just inside a normal response processor in Enonic. And I'll just get our content security policy from the headers and change the script source and add this nonce. A nonce is just a variable that have to be random. So we create our nonce from a Java code and use a bean in here to get the nonce, to make sure it's actually random. And then we have to add this attribute, the same nonce variable, to our script. And I'll just add the script in our body begin here. And since both this script has this attribute with the same nonce as is now added to the content security policy, the browser will allow it to run. Yes. And then this is finished loading, and I have just added this very nice script here that adds an alert box. That's why I didn't want it to run, because this is a bit annoying. But I want it to run now. And I'll see if I refresh here, it doesn't run. But Chrome tells me that it is because it violates the following content security policy directive, script source, and it tells me that I can use the unsafe inline. Don't do that if you know what you're doing, don't do that. I can use the hash if I want to, and this is actually the hash I can use according to Chrome, or I can use a nonce. I want to use a hash here because I know that this is what it's supposed to do at all times, and if I change something, I know it, and I can change the hash myself. So I can either just say that, okay, Chrome, thank you, and I'll use it, or I can calculate the hash myself, or at least through a web page that supports me to do that. Then you have to copy what's inside the script tags, and every space and everything counts. So if I had added a space here, a new line here, then that will be added as well. So make sure that you actually have what's between these two scripts. And I'll add it here and calculate it. And the reason we don't want it to use this, if it can vary a lot, it's because if I add a space here, then it's a new hash. And we don't want to be doing that all the time. So I'll go back that. And here we can actually see that it's the same value as we got from Chrome. So I want to accept this. So I'll just go back to security headers in the script source, because it's a script I want to load, and add it here. Apply. And we go here, and yay, it works. My script is running. Yes. And now I hope it goes back there. Thank you. So, key takeaways here is use the security headers, and it's quite easy to use in Enonic with the security headers app. And for content security policy, use the strictest value as possible. Ideally, do not use unsafe inline. And use hash if you have a static script or style that you need to allow, or nonce if it can vary, for example, through variables set by the editors. And here are some of my sources, like Mozilla and OWASP.